Real quickly, I'm going to go over the anatomy of this waves equation. Y parentheses xt equals a, the sine of kx minus wt plus phi. You will use this equation if you're trying to locate something on the y-axis at a particular place along the x-axis at a certain time. In other words, just say if this is the y-axis, this is the x-axis. If you have a buoy here, rubber ducky, whatever, going in this direction at a particular distance, say 10 meters, at a particular time, say 5 seconds, and you have all this other information that's listed, you can find out exactly where along this wave that particular object is. That's the purpose of this equation. So the y is the up and down direction. X means at a particular distance to the right or left, time at a particular time period within 5 seconds, 10 seconds, or whatever that may be. One thing I want to caution you on a test, when they give you X or T, don't plug X or T in here as well. You only plug X or T into these two areas. It looks kind of confusing at first. You may be tempted to plug it in here. If you do, you'll mess the whole equation up. That's simply an expression of the function of y. A is the amplitude. Amplitude is the distance of a wave from the x-axis. It's how tall the wave is. Sine, if you remember from your earlier physics, anytime you use the sine function, you're trying to locate something along that y-axis. So if you got y-axis, you're going to have this little sine function there. Kind of goes hand in hand. Just know sine means something along the y-axis. You'll have another equation that you'll use that I will make a different video on when you're trying to find velocity. That uses cosine, which means we're trying to find something along the x-axis. K is the wave number. The wave number is simply how many waves do you have in a particular distance. So if you had a wave on an x-axis this way, the wave number is how many waves do you have within a particular distance. Let's just say this is 10 meters and this represents one wave. This is a complete wave cycle, and you have another wave cycle that goes here. That would be 2 wave cycles within 10 meters. That is your wave number. W is your angular frequency. It's the number of waves that you have in a particular time period. If you have a stopwatch and you have 10 seconds on there, how many waves did you have in 10 seconds? You can actually find angular frequency with 2 pi over period. Period is represented by a t. So t equals period. So if you have period, you have your 2 pi. You can find your angular frequency. Likewise, 2 pi over lambda here. Lambda represents your wavelength. So if you're trying to find k, you can do 2 pi over wavelength. That will give you your wave number. Time is self-explanatory. What time period in question are you looking for? So if a wave started at 0 seconds, 5 seconds later, where's my object? And a phase shift would be if you started out with a wave at this particular point and you picked back up here, this will be a phase shift. The distance between the two waves, say this peak and this peak, And my picture is not symmetrical, so you kind of get the idea. But the distance here between these two peaks will be your phase shift. This represents your phase shift. Now, if they don't give you phase shift in a problem, you can just ignore it, because this formula, you have a positive sign here. So if they don't give it to you, you can ignore it and still find what you're looking for in a particular problem without having phase shift. So you don't need phase shift to find this problem, but you find the solution to a problem like this, but you pretty much will need every other variable that's in here.